Hello, hello. Can you hear me okay?
Yes, everything is okay, and I hear you perfectly.
Wonderful. And hello, everyone. Welcome to this month's Chicago Kotlin user group. Today we have Anna Zharkova guesting today. Um, Anna, where are you speaking from?
Hi, Amanda. Hi, everyone. I'm a speaker from Russia, and I live in Barnaul. It's in the cold Siberia. Yes, and we have really a lot of snow today.
We're not in Chicago. We're not quite there yet. Like I think I saw a map where the all the snow is kind of like at the border of Canada, just because winter hasn't arrived quite literally yet. But it's very close to us. It's coming. So. Oh wow, we have some folks from different countries tuning in today, so this is kind of fun. Hello, everyone. It's really nice to hear from all of you. And Anna is going to be talking about, working with Kotlin Native. And how long have you been using Kotlin for, Anna? You're a Kotlin GDE, so it's an honor to have you on the show today.
Well, I work with Kotlin for 4 years, and Kotlin Native I use for about 2 years. Since I become dealing with Kotlin Multiplatform and Kotlin Native, I use to develop iOS software. I am both Android and iOS developer, so it is really useful for me.
Oh my Lord, that's so awesome. I already have questions. But I don't want to take away from your talk time. So I'm really excited. I think other folks are going to be pretty excited as well. And just to let folks know today, if you have questions, feel free to put it in the chat, and I'll be sure to read them out at the end of the talk. So yeah, please definitely put them in the chat. Feel free to put in commentary too. Sometimes I like sharing those. Um, yeah, Anna, I'm gonna run through the logistics, and I'm gonna put you right back on. Yeah, really excited to have this talk with you.
Thank you very much. So I'm waiting.
Thank you. Let's see. And hello, everyone. Welcome to the Chicago Kotlin user group. Today's talk is called Kotlin Native, Dealing with Old and New Memory Models. Anna's a Kotlin GDE for those that are tuning in. And if you don't know about Chicago Kotlin user group, we believe in being inclusive. So CCUG is an inclusive group. It means be curious, ask questions, and avoid assumptions. And we might be in pandemic, but you'll always want to do everything to continue to grow trust, empathy, and friendship. Okay, so we do have an open CFP link year round. I believe this is our last talk for this year, but we're always looking for new speakers. We've had a lot of amazing talks, both from incredibly experienced folks and also new speakers alike, and they've all just been awesome. So please take a look at the link provided on the description for the YouTube chat. It should also be in the meetup. Yeah, it's a great way to practice talks, and it looks great on the resume. And of course, it's a great way to expand the network. So definitely do it. We're always looking for new speakers. Okay, you'll be hearing my birds in the background occasionally. This is their most active time of the day, it being 10 a.m. and all. So there's a couple ways you can reach out to us through the Kotlin Link Slack. We are on the we're on the Chicago channel, and also we have a Twitter for Chicago Kotlin. So be sure to follow us on there. So for today's interactions, please refer to the YouTube chat. I already see a couple folks commenting, so it's very nice to hear from you. And of course, please follow Anna on Twitter, or you can also tweet us. We'll be tweeting some things from the talk, so be sure to do that. I think that's everything. Anna, I'm adding you back on. I'm going to give you the floor. Yeah, please take it away. Thank you so much.
Thank you very much, Amanda. So I'm going to start my talk. Well, I'm trying my slides. Everything is okay. So, hello everybody. Good morning, good day, good evening, no matter where you are. My name is Anna Zharkova. I'm lead mobile developer from UseTech software company, and I'm also Kotlin GDE. And today I would like to speak about Kotlin Native and how to deal with old and new memory models. It will be useful for everyone who are interested in Kotlin Native, Android, iOS, and Kotlin Multiplatform. So, at first, a few words about myself. Let me introduce me more detailed. I'm also native mobile developer and do both iOS and Android software. And I'm fond of cross-platform mobile development, especially Kotlin multi-platform. And also, I'm lead of mobile team. I'm a mentor of my team, and I'm a public speaker. I'm a tutor, and I write articles about mobile development, especially articles in developer expert group. And I'm a Woman Technique Ambassador and Kotlin GDE since this year. So let's take a look more detailed on my talk. It's more interesting that information about me. Today we'll be discussing about Kotlin Multiplatform and common concurrency. Also, we will talk about coroutines, solve problems in Kotlin Native, and then we will look more detailed in background workers, advanced sharing, flows, and Kotlin Native, how to deal with this from iOS side, and also we will talk about new memory model in Kotlin Native. So let's begin. At first, a few words about Kotlin Multiplatform. It's cross-platform SDK to develop cross-platform software. It was introduced by JetBrains company, and it is a special SDK, not a framework, that let you to create some uh, common shared model of your code and to share it as a framework with iOS application or jar library with your Android application. And why it is not framework but SDK? It has no functionality to deal with UI, and it only allows you to share a lot of code that could be commonized, and it allows you to use especially tools for differently for Android and for iOS. For example, it uses JVM to compile code as Android library, and LLVM to compile code for iOS as a framework. And it deals with not only mobile systems. Kotlin provides special kind of version of Kotlin language for every platform. For example, it uses Kotlin JVM for Java applications and for Android applications. When you deal with desktop, Linux, Windows, and for example iOS applications, you need to use Kotlin Native. And for JS and web, it uses Kotlin JS. So every version of Kotlin is not similar. It has some common, but it has its own platform specifics and allows you to use it only with specified platform. Um, and it is a reason why a concurrency in Kotlin, when you use Kotlin multiplatform, it's not similar in JVM, and it's not similar in Kotlin Native when you do both Android and iOS applications. To deal with this, you need to use special constructions as expect actual and to define expect variables for coroutine these pictures, and redefine it as actual and implement with special native implementations in native iOS side and native Android side of your common code. So it's a interesting construction of common shared model. So it has common part that allows to use only common code, and it has also some platform-specific targets in which you can redefine some aspects of your code to add some native implementations, and you use only Kotlin language, but with platform specifics that are um, available for this special platform. So here is how it works with the dispatchers. And also when we use such things as networking, why we speaking about networking when we speak about memory management and multi-threading. So it is the main case when we need to use multi-threading. I don't think that nowadays we can find any application without networking, and networking is the main case of using multi-threading in every application. So Kotlin Multiplatform, it's not about UI, so we cannot use such things as animation as a correct sample example how to deal with multi-threading. So we use networking case. In networking, in Kotlin Multiplatform, we can use common implementation with such libraries as Tor. Uh, it was it has different implementations and special implementation for Kotlin Multiplatform version, and it used coroutines under its hood to provide multi-platform logic. And also in separated native targets, we need to use coroutines, special native versions. And how to deal with it is depends on specific of your platform. So yes, at first we will take a look about how it works when we add Tor implementation in our application. So at first it looks similar, and to provide coroutine logic, we need we need to add some steps. For example, how it will be working with Grand Central Dispatch. Grand Central Dispatch is a main mechanism to deal with concurrency in iOS side. So Kotlin coroutines use suspend functions, and suspended Kotlin functions is transformed into Swift functions with completion handlers since Kotlin Native 1.4, and it's absolutely correct to use it in both sides. So when we speak about how to deal with concurrency and how to put all the versions together, how to put all the code together, we need to think about common architecture. At first sight, when we use concurrency only in special native targets and we not put Kotlin concurrency in common code, it will be no problem at all because it will be separately implemented in all targets, and it will be no collisions. But it is not what we are talking about today. Um, in ideal situation or the ideal world, we can use not only common networking for Kotlin Native, but and Kotlin multi-platform, we can use common architecture, and we put all the code that use coroutines and networking in one common model and call it only from your native parts directly. So in this case, when we use common architecture, we need to provide common coroutine scope, and that is why we need to expect we need to define expect cartoons dispatchers, cartoon context, and redefine it as actual in both iOS and Android native platforms. So when we use Android, we can use default dispatcher. Dispatcher default we can use for for implementing and background working. Yes, we need background working when we use networking. And for a main UI, we need to use dispatcher's main. And if we take a look under its hood, we will notice that dispatcher's main is also unique for every platform, and it is made with a main coroutine dispatcher that will find correct dispatcher for your platform in special factory of the dispatchers. So if there is no such kind of dispatcher, you will get an error, an exception, and you cannot easily use this code. And you need to implement something by yourselves. Well, there is some kind of solution for it. We will speak it later. So let's take a look what we'll be doing with Kotlin Native. We will not speaking about how to use it with Kotlin JVM because Kotlin JVM is absolutely the same as we use in our daily life when we provide logic for Android applications. So it's everything. Everything is okay, and we need to focus only in Kotlin Native. So at first sight, we can use same kind of dispatchers. And if your code use no sharing of context, no sharing between threads, it will be okay for you. For example, if you define something in one thread and use it only in this thread, it will be okay. But when you need to share context between your threads, you will get such kind of error. For example, it is an error from Ktor, and we will notice that there is some kind of freezing exceptions. Um, so it looks really strange because we implemented it by default and used provided mechanism. What can be wrong? So let's take a look what could be wrong. If you will search for some kind of information, you will find that there is some kind of problem with dispatcher in Kotlin Native for iOS. For example, dispatcher's default is not bound at the moment for any background thread. That is why you need to provide your own dispatcher. So let's do it by ourselves, and we will make some singleton objects that will redefine coroutine dispatcher base logic, and in overrided dispatch method we will put our code in special dispatch queue. For example, when we need to implement a dispatcher for main thread, we need to put everything in dispatch sync dispatch get main queue. It is the same way we use it in iOS application when in native way we use Grand Central Dispatch. So it is a Grand Central Dispatch for iOS that is available from Kotlin code. And let's do the same for background threading. We will make some kind of background dispatcher, and we will use not main queue, it's only for UI, but we will need to implement it with global queue. And at first sight it will be okay, but problem is not solved. And we also have the same exception. So what is the problem now? Well, yes, here is a moment that dispatch default is not bound to dispatch get global, and also we cannot use dispatch get global directly because it's also not bound to any background thread at the moment. So it's a problem. But when we use Ktor, it's already implemented all multithreading under its hood. So we have no need to use background threading over the Ktor. So we can use only main dispatcher. Sounds good. Also, we have a question: what we should do when we use no Ktor in our code? And we will speak about it later, few minutes. So, using coroutine dispatcher with Ktor code, we use both main dispatcher for background and UI threading. In one side, when we use another different scopes, different jobs for our code, it will be okay for coroutines in this case. And we also need to put one interesting construction on command block run freeze. So we need to use freezing to solve our freezing exception. Why? Here is one rule about working with threads in Kotlin Native. Well, we know that in every platform, in every language, we need to use mutable only one thread and immutable in multiple threads. In other ways, we can find such problems as leaking, miscontext, and so on. But in in Kotlin native case, it's really critical. We're not speaking about JVM. In JVM, everything is okay and already done. So we need to share the context. We need to use it as immutable. So we need to make it immutable. To do this, we need to freeze it with special command, and also we can use it in our background work in this way. So though we use some special kind of get global queue, um, we have a, uh, we have a hope that it will be working in this way. So maybe yes, maybe no. I haven't tried this code, and I will also show you another way how to use it with global queue. So why not to use global scope? We use coroutines, and coroutines is has its own mechanism to background working. For example, let's do it with global scope. And at first sight, it was designed for background working, but it is not recommended because we have potential leaks and losing of callbacks. And to deal with this, we need to um, fix it by saving the context, by saving all our jobs. And then when all our jobs are finished, we need to clear it in case to not to keep everything in our memory. So our memory is not infinite. Um, well, let's take a look that we have solved all our problems at first sight. Yes, we haven't solved it, but let's think that we have. So we have one problem, and it is a problem of singleton. As you remember, we use singleton to deal with our dispatchers, and you need to know that singletons are constants and frozen by default. And when we will use it with our actor, for example, in sharing context, we will also face same freezing exception. To deal with this freezing exception, for all immutables that are singletons, backend fields, or objects, we need to use special annotation thread local to allow it to be shared between threads. And in this way, we will add some kind of this annotation in our service. For example, in my small sample, I use singleton to not to deal too much with architecture. So that is why I will put it also here and also in my dispatchers, and everything will be working okay. But it seems to be really over engineered and seems to be some kind of strange solution at first sight, and we haven't solved with background threads. Yes, we have found solution. We have found solution to deal with threads when we use Ctor, but um, I think that it is not only way to deal with it. So we can do this not only with curtains. So let's begin. And at first moment, we need to deal with synchronization because it's really important when we provide solution for Kotlin Multiplatform, and we need to deal with thread and sharing of context correctly. So we know that there is also one problem of synchronization, and synchronization could be used and should be made in our code differently because Android is Android, JVM is JVM, and Kotlin Native for iOS is Kotlin Native. So to provide your safe read and write, we need to implement synchronization differently. For example, for iOS, we use monitors and mutex, and we need to use synchronized constructions for Kotlin JVM. And then we can use it as expectextual in our code. Um, So let's take a look how can we use multi-threading to find a final solution for background threads and to work without coroutines. Someone has implemented it in Ktor. So, and that is mean that we can also find this solution and we can also use it in our code when we need to define it separately and to do everything all by ourselves. So at first, let's make some kind of sample and we will define some kind of network clients. We will work here without coroutines and we will define some kind of interface and implement it with our classes in Android and iOS parts of our common model separately. So now let's take a look. How can we deal with iOS HTTP client and use Kotlin native mechanism without coroutines? So to deal with this, we need to define some kind of workers. Worker is a native mechanism that provides background threading. So at first, it is our sample. It is a code for our HTTP client, its network engine, that use the same code that we will implement it by Swift with Swift in iOS native application. So it is code written with Kotlin, and now we need to apply something to work with multi-threading correctly. So um, here we need to put some background constructions, and also we need to provide our code to route it in main thread. And to do with this, let's add some kind of worker. How it works? We need to define worker with worker start construction, and it will provide to us a future that will be executed in safe way. By default, it is not safe, and we need to use transfer mode safe to make it really multi-threading safe way. And then we also need to put some kind of block of code and to consume everything in working code. And then we need to put all our features together and listening for them and then clear them to prevent memory leaking. So here we use some kind of freezing. I have implemented um, some kind of construction and defined freeze blocking as here. I think it looks more uh, interesting. And here in final block, we receive the result of our work. So how it works with multi-threading. And in background work, we will put our code, for example, just like this. So all this code is will be started in background, and how we should do with the multi, and also I here add some kind of completion block to get the result. So now let's take a look how to deal with main thread in this way. So for main thread, we need to add some other solutions. So at first, let's add some kind of callback code, and we will put it in some kind of future consume construction. In this part, in this of your flow, you will receive the result, and then you can put it in your callback. But it is also for same thread. We cannot switch here to another thread. And to deal with multi-threading, we need to implement the block of code is the same way we used it previously when we defined our own main dispatcher. And in this block of code, we will call our callback and it will be returned for us in a main thread. Looks really nice. Let's add it in our code, and also to prevent freezing exception or invalid mutability exception. because everything will be shared between different threads, we need to freeze everything. Yes, it will be working. It will be working, but sometimes it still crashes because we have forgot to deal with mutables. Um, when we make some kind of network request, we need to get some result and to show it to our user. And in many cases, we receive our answer not as single block of code, but sometimes it could be split in different blocks. So we need to put all these blocks together. And on first side, we can provide some byte array, and then in some method where we receive our code, we need to add all our code in this array, and then when we have received a flag that everything was completed, we need to deal with all this code, and then we can return it to our user. But when we have frozen everything, we have frozen also this variable, and it's immutable, so we cannot change it at all. What should we do to share it correctly? So we cannot use thread local because it's not singleton, it's not backend field, it's not object. And we can also try to use thread local annotation from Tor code, but it is not the solution for us because um, it also will make us freeze an exception, and we have also already freeze it, so it's frozen, and it will be freezed one more time, so we'll get freeze exception. It's not the way we need. So in this way, in this moment, we need to use such kind of atomic reference wrapper. I'm sorry. And this atomic reference will help us to deal with sharing data and making variables mutable, to make mutable what was immutable. So, and first we need to put in this atomic reference wrapper our variable, and it will be at first frozen. It should be frozen, but it's not perfect solution because it causes potential leaks, and we can fix leaks by clearing everything at the end. So when you have received all the data and you have all this data um, recognized and sent to your user, in this moment you can clear all the variables, so it will fix all leaks. So how to deal with atomic reference wrapper? At first we have frozen it, so I use some extension atomic that will turn everything in atomic reference. You have seen it in previous slide. And to make new data, I got everything from all value, and then I add some new portion of data, and then I put it in my variable, my global variable, not global but variable of my class, and I have to use freeze to make it mutable, and then it will be everything. It will be okay to deal with this. So also, I can use such kind of solution as detached object graph. It also allows me to work with mutables and immutables and share data between the threads. But how it works? At first, we need to provide some kind of feature, and we will got some kind of pointer as detached object graph. It will be pointer for some kind of memory with our, for example, variables, our input, our block of code, and some kind of block in which we will send our result. So we use some kind of tuple, triple tuple, for example, and we also need to make it immutable. and put it in our graph and then use a pointer of it. And so we need to define it in one thread, for example, in which we are working. And then when we need to get, for example, in main thread, at first we shouldn't forget that we received all the data in background threading and we need to put it in main thread. And then in the block of code where we call dispatch get main queue, and we also put here our pointer to our detached graph. In this function, static function, we need to attach our graph, and then we need to get all the data from our pointer, our attached pointer, and to use it, for example, as a second variable, as a second parameter. We have defined block of code where we will put our first parameter, the data, and then in the third parameter, our callback, we need to put everything back. And the problem is we can attach our graph only one time. Every time you need um, to make it one more time, you need at first define your graph, then you need to put it in other thread, and then you need to attach it. In other way, you will get an exception. So it's not good. If it looks to you really complicated, I have forgot to say that everything will be working when we use background threading and main threading with workers. So if it looks for you too complicated, let's return to coroutines. So all this information is information how it works with all memory management. So I will show you how to deal with coroutines and all this mechanism, and then we will speak about how to deal with new memory management. I hope it will help you to wait for these slides. So let's return to our context and let's speak about how to communicate between context with coroutines. So Kotlin coroutines provide different mechanisms for this: channels, flows, and completable deferred. So um, at first, let's use channel to put all our data, and we will also use the completable deferred to make our function available and suspended. So in special complete block, we will add all our information to our special channels, and it will help us um, to make it more sophisticated than using just atomic references in this way. And we will use a raw response to with available deferred mechanism to make it to turn it into a suspended function and to make it available for coroutines. So same way we can use to define it with mutable state flows. It's the same mechanism, but if you will take a look, you will notice that we're still using share freezing mechanism, and we have redefined and changed some logic only in some special kind of reader where we have previously used atomic references. So in the main part of HTTP engine, we have to still we're working with background workers, and at this moment there were no other changes in that part of code. So we have to define coroutines here to implement working with reading in more easily way. So also, to deal with flows, we need to define our special scope that will be working in this part of code, and also in special collect part, we need to to collect all our part of data together, and then to turn it to some kind of data and send it to our user as available function. So now let's add some kind of coroutines in our engine to deal without background workers, and we also use here our special scope. I think it will be better to define it here and then to use it in our reader, for example. And to deal with coroutines and not with background work, we just remove all background work code and put all our launch in scope launch method and scope launch callback. And here we solve problem with lambda sharing. So how so it looks more sophisticated, more beautiful, and no special kind of really hard code. But if you need to use all our background without coroutines, you can use background workers. So you have noticed that we used mutable state flow in command code, but we know that mutable live data, one of the really popular mechanism in Android, is used only in Android part because it's JVM, it's Android. And we were speaking about how to work with common code in Kotlin Multiplatform. So common code, iOS, Android, live data is for Android, but what about mutable state flows? So it is a synchronous flow state of live data, and it could be used in common code, not in iOS native part, but in common code also. So let's do some steps to use it directly from our iOS site. So when we will call our logic to define a special kind of flow, for example, in previous slide, there was a sample how to put all our data in special kind of flow in our view model. It's not view model as it was made for Android and uses view model Jetpack mechanism, but it's your own handmade view model that defines your own special scope and dispatcher. And here in this part of code, you just listening for events and put it all together in special flow. And then you're listening from iOS and Android sites to get all the data from these flows. At first, when you call directly flow from iOS site, you will get this kind of steps in your collect method. So it seems at first sight that so we suggest that it will be only completion handler block, but it's also a special collector, coroutines core flow collector, and it looks really strange for any iOS developer. It means you need to use your own collector, and to deal with this, you need to define your own class that will be a derived class for Kotlin X curtain core flow collector, and this class should redefine emit block, should override it, and in this special emit block, you need to put some code, some completion block that will get all the data from your flow. If you will put all these blocks not correctly, for example, you will forget about completion handler, you will miss some signals and it will be critical for you. Um, Also, you can define your own wrapper that will implement all coroutine logic here. So in this, it will be a wrapper for any flow, and in special collect function, it is not coroutine function, but it uses coroutines in it. You will get all this data and you will send it to the callback of this code. So also, to make it more sophisticated and to make it more safe, you need to make it cancelable and to add some special method to cancel all code. And in iOS site, you will call it simply. For example, it's not just initialized variable some flow. Let's pretend it is some kind of variable that previously was defined in your code, and you're just listening to its changes with special collect block, and you also receive a signal when it was completed and when you can do some kind of logic as a finalization of your operation. So that was how to work with flows in iOS side. Um, we know that everything okay with Android because Android is JVM, Kotlin Common is JVM, so everything is okay. And now let's take a look in new memory management model. It will be something really interesting. So this year, JetBrains company prepared for us really something interesting because it is some kind of solution that will solve all our problems. And this solution supports safe sharing and changing of thread context. And that means that we can use multi-threading without trees, and that's cool. Also, atomic references and freezable atomic references, this kind of mechanism that we can use to wrap and share data between our code, could be used without leaks. And also, we have no need to share immutable annotation with our global constants. And also, we can use workers without isolated graph of dependencies. So that's okay, and that looks really nice. It seems our code will be clearer, and we can remove all freezing in from it. But here is some disadvantages. Atomic references still need to be freezed, and I'm sorry, to be frozen. But you can use freezable atomic references instead. And global constants are lazy, so that means until you will call them, they will not be created. And to make them initialized immediately at the start of application, you need to use eager initialization annotation. So instead of one annotation, we have to use another annotation. But lazy variables seems to be okay when you don't need them at every moment at the beginning of your application. And also, the main disadvantage that there is no guarantee that when you will call suspend function, it will return your block in main thread. In previous versions, when we use suspend functions, we have to use null dispatch queue wrappers to send it in main queue. Yes, when we implemented Ktor code, it was also a main dispatcher that used dispatch get main queue to route everything in main thread. But in this way, we need to also directly put such kind of wrapper in our iOS code or to add some kind of wrapping in UI dispatcher context, for example. Also, the init could be called in other thread, and it's also some kind of disadvantage. So we should use it carefully in our code, and we need to remember such details to prevent crashes and memory leaks. So to migrate our code in new memory model, we need to use Kotlin version 1.6 version for M1 on your. In my sample, I used 1.6.0 M1 139. And if you are iOS developer, you need to use Xcode version 12.5 on your previous version are not compatible with it. So, and for coroutines, you need to also use some special version, 4.51 new memory module and branch dev 2, and Factor it's also special kind of version. So, so let's take a look. We have already defined everything in our code, and now let's do some migrations with other moments. At first, remove all freeze blocks from non-coroutine version. Even from background workers, we remove all freeze blocks. Done. And now let's remove everything from other parts of our code. For example, from our HTTP engine, we will remove all freezing for sessions, for tasks, and so on, also for all our global uh, and shared variables. Also, we will remove everything that could be freezable from our flows and channels. Done. And same with our freeze atomic references. So I don't want to use freezing at all. That's why I will turn it from atomic reference to freezable atomic reference, and it will solve all our problems. Done. And also, let's remove freezing from our code for atomics. Um, well, you will ask me, Anna, why we still using atomic references if we use no sharing and no freezing? Uh, you know that we still using sharing context between threads, so that means that we to prevent all our leaks, we need to use it with atomic references. So we need to still to use this mechanism. And let's take a look at our dispatchers. So new memory management model also means that we shouldn't define our own dispatchers. We can use only dispatchers main for UI dispatcher and dispatcher default for our coroutine context. And it will uh, run this code. For example, for coroutines that do something in background, we will see such input, such output. I'm sorry. And this Darwin Global Queue Dispatcher means that it is real background bounded dispatcher default for your Kotlin Native. And that means you can use it safely in your code without any other actions. No need of your own dispatchers from this moment. And you can use it safely without any memory leaks in your code. Just define default dispatchers and no need of background threading at all. No need of background works if you work with coroutines easily and no problems. And one more thing that we can use in our code to deal with multithreading without coroutine context. It's new single thread context. Previously, this mechanism could be used only with JVM and Android code. And this special kind of a single thread context will create for you your special dispatcher with your special worker. So it's a mechanism to implement some kind of built-in worker, and it could be called from your coroutine context. So it's your own way to create your own dispatcher with your own worker, and it works perfectly with iOS. But this is not perfect at all. So there is some kind of disadvantages in this memory management model. So it is not final version, it's still developed, and when it is not stable, there could be some problems. For example, problems with freezing. If you use versions of libraries that not that supports No new memory management module. They support old memory management module. You need to disable freezing default because in other way you will face freeze exceptions, and you can do this with two variants. For example, you can define in your Gradle properties Kotlin Native binary freezing disabled, or in your Gradle build file in your script you can define binary options freezing disabled for any Kotlin Native target. Also, there is a problem of memory leaks because JetBrains still work on memory management and garbage collector need. So you should be careful in this, and to deal with all leaks, you need to use auto-release pool in some critical sections of your code. So let's summarize our talk. I hope it was interesting for you. So um, now there is no limitations uh, to choose your UI approach, so you can use everything. Um, so any solutions begin from workaround and um, oh my god, I have found it as my old wrong summary. So let's summarize it in other ways. So um, yes, PowerPoint was not good for me today, and this was not kind for me. So let's summarize it correctly. New memory management model is a really cool thing, and I advise to everyone for you from of you to use it in your work if you have no need to use some kind of specified libraries that use old memory management model. It will be really cool solution for you. Um, Nowadays, more and more library supports new memory management model, and I hope that in spring of 2022 we can use it as a stable version, and we will forget about everything about freezing, strange dependency graph, and so on, and it will allows us to use all mechanism easily. Well, I hope and I think so that background workers and dispatched graph will stay with us as a Kotlin native mechanism under its hood, but to deal with and without coroutines, we can use easy mechanism. So, and Kotlin Multiplatform is cool, Kotlin Native is cool, and it's a new way for you it's new horizon for you to deal with it and to make some kind of cross-platform solutions without any need of some kind of strange workarounds. So it becomes more and more stable. So we will be waiting for beta version, and it will be cool, and it will get us many improvements for Kotlin Native and Kotlin new memory management model. So here is some special and useful links for you. For example, here is also my library, some kind of useful links that will that, and you also can find here some kind of solution I implemented in GitHub, and some useful links for you. So thanks for listening. I'm waiting for your questions, and subscribe for me on Twitter and on Telegram. Though I wrote mainly in Russian, I promise that I will also write in English. And yes, I will put here also a link on my English Telegram and Twitter.
Thank you so much, Anna. That was a really great talk. Yeah, folks, if you have any questions, please feel free to put them in the chat. I'll be sure to read them out loud, give some voice to it. I have actually like one or two questions myself. Really quick, what in the previous slide, which one is your library? The KMM concurrency one?
Yes, KMM Concurrency helper, and also you can find in my GitHub a link to KMM Native Network Client. So in this GitHub, I Let me send you correct link on chat. One moment. In
Yes, please
this,
definitely post in the
yes,
chat,
yes,
and
yes.
that'd be great. We can
Uh,
also share it in the description. I'll be sure to edit that.
so in this library, I work with Kotlin common network client that uses native mechanisms without coroutines and also coroutines version. So I use it not as some kind of production software, but it will be useful for everyone as a good sample. I hope it is a good sample how to deal with native mechanism of concurrency. So I've put it in chat.
Thank you so much. Yeah, I'm definitely gonna tweet that one out too. Yeah, no, it's I find those to be really really useful. Lots of folks when they try out brand new technologies, like it's a very popular method to look at completed like sample projects as a way to get it off the ground. So incredibly useful. It's a great contribution, especially in an area where there's just not a lot of content on it. Yeah. Okay. Wait, my question. So what, just out of curiosity, what is like the most expensive workaround you were willing to do? Um, and I would presume that maybe the workaround would have been for like the iOS side.
Well, I begin from the cheapest workaround. The cheapest
Okay.
workaround is just to use really it's just used tool, for example, and thread local annotation to deal with all singletons in your code, and it will it will define for you all the code with concurrency. But when you use your own made concurrency, well, I'm I'm not advised to use detached object graph because it could be um, really too complicated solution for you. But the easiest way is to define a worker and dispatcher for your main thread. So when I was implementing my sample at first sight, the most the hardest moment for me was to define how to deal with mutable immutables when I need to put all my data together, because I was really surprised that everything was shared and was frozen when I froze another part, that when I put just a link, just a quick reference of my engine in some completion block code, so not only the completion block was frozen, but the parent and the sample there of my class was also frozen, and it was
Oh
really a
wow.
surprise for me to find a solution. And yes, the main problem was that before a new memory management module was released, you're right, Amanda, that there were not too much information, but there were also a nice solution from Code Labs. But though this solution was, I don't think it's too old solution, but it was not particular solution for particular case. What we need to do when we, for example, use backward networking, I don't. I think that it is a main reason why not too much people, though they have read this article, they began to use the solutions from this article and also the solution from the documentation, because to understand that this solution is applicable for you and it is solution of your problem, you need to dig in the documentation and to use really a lot of different solutions, different workarounds,
Mhm.
and some on sleepy nights you will finally realize that here is a simple solution for you of your work. So, and I think that it was one of the problems of deep using of Kotlin multi-platform for deep solutions. Um, for people who were struggling with the Kotlin multi-platform, and they were thinking, they thought, what was better solution, to still use Kotlin multi-platform or to switch to Flutter, for example.
Yeah. So that's a really good question because I'm not going to say like every company goes through this, but it is a scenario that companies do go through. They're considering multi-platform at one point. They want you to investigate Flutter, React Native, Kotlin multi-platform. So, what are like some of the items with Kotlin multi-platform that sold it, like for your case, for the business case that you're like trying to serve? Do you have any like helpful pointers for folks that might be wanting to do like Kotlin multi-platform at their work?
Well, no. I also search information on special Slack channels, and
Key.
yes,
Yes.
Slack
Yeah.
channels, and also I've decided to switch to surf information in Google, the easiest way.
Of
But
course. Yes. I'm very
yes,
much also a Googler, professional Googler,
well,
really.
yes, we are everyone a professional Googler in this point, and the problem was that the only people I can ask about how to deal with this were the people who work with Kotlin multi-platform. Then the JetBrains company, or maybe Ktor. And I found that it's really strange to ask Ktor about, hey guys, what the mechanism you need under your hood to deal with that coroutines with concurrency. So I tried different solution. I found different solution, and I found a solution. I asked one good library. It was a really good library to provide different samples of concurrency. But and from them, I knew about workers, but also there were some
Amazing.
not. Yes,
Yeah.
yes.
No,
The
this is how
yes,
languages
it
evolve. I just love hearing stuff
yes,
like this. Yeah.
yes. In this moment, at this point, I wasn't Kotlin GDE, but not everything was good for me in this solution. It was only workers, but I need to provide solutions to deal with atomic references. So I have to dig by myself, and then I found it. I decided that everything is written in Kotlin documentation, and it was solution in Kotlin documentation. But I have to realize that this was solution, and there was not directly solution. And this point is, when you see something in documentation, you need to understand how to implement it with your code, how to put it in your code, and how to put all these blocks together. So I hope that for everyone that struggles moment with Kotlin concurrency, that now they know that there is also people who already implemented solutions. For example, they can write to me and ask me how to deal with it, and you are welcome. There is no problem. I will help you with something because I'm Kotlin GD and I also struggled with this point.
Wow, thank you so much, Anna. That's great. That's a wonderful invitation. And Twitter seems like a good avenue. Is Kotlin Link another potential avenue? What's the preferred method of contact for
Well,
questions?
for questions, everyone could contact me both by Twitter or my Telegram. For example, Azure Zharkova is my personal Telegram, and there is no problem to write me on English. Well, Pretty Geek Notes is my channel, and mostly it's information in Russian. But you can also contact me about some special details. Also, you can find me on GitHub and contact me here. So you're welcome any way that is appropriate for you. You can use it.
This is amazing. This was a great talk. Sorry about that. They're excited. They're like, it's amazing to hear. This is truly a case where you're somebody who happened to end up stretching the bounds of what currently exists in Kotlin. So, congratulations. That's like cutting edge stuff. I love it. Thank you for sharing all this. I hope you don't mind. I'm
Thank
going
you.
to tweet out your open source library. Someone said, thanks a lot for providing that interesting and useful information. I thought it was a great talk. It was really informative. It's really in depth. If you don't mind, like sharing the slides after or something like that, or like links
Yes,
or anything
I
like that.
can. Yes, I will
Um,
send you a link for
yes,
my
yeah, yeah.
slides.
And we can be sure to just post it everywhere after. This was awesome. Thank you so much again.
Thank you for you. Really, thanks one more time for your invitation, and I really happy that my talk was accepted by Kotlin Chicago group, and it's cool that the community of Kotlin developers is bound from all over the world, Chicago and Bono now, for example, and it's really cool that
Awesome.
our network
Yeah.
becomes wider and wider.
Yeah, and everything feels smaller. I mean, today, oh my goodness, they're flying today. Yeah, there's speakers from Germany, Ireland, Russia. This is such a great community, and I really enjoyed doing this. And also, this talk was just like, sometimes it's hard to get good focus, like in-depth talks, and this was like just really well covered. Thank you again, Anna. This was wonderful.
Thanks for you.
Thank you. Okay, folks. I think we're gonna end it here. But yeah, please stay tuned. Like I said, we have a open year CFP all year round. Check out the description for that. And please keep an eye out for links that we'll be posting after this. Okay, thank you all so much. I hope you all have a wonderful end of the year holidays, and we'll see you at the beginning of 2022. Thank you, Anna.
Thanks, Amanda, one more time. And I wish everyone nice Sunday or really productive Monday. For example, for everyone who are not who are going to go to work some hours
Very
later.
soon. Thank you all so much. Yeah, have a good night and a good morning, everyone. Take care.
Goodbye.